the webinar. My colleague Dennis and I, Alexei, are excited to walk you through the amazing new features and enhancements of Rapise 9. Version 9 contains many new features, enhancements, fixes, and improvements. You may learn more from release notes available in their usual place on rapisedoc.inflectra.com. Today we are going to cover those key and most exciting features of Rapise 9. And here is the plan that we will follow in our demonstration section. I know many of you were waiting for this new self-healing functionality, and it's high time to showcase it. I've just installed Rapise 9, and I have Spira instance with Inflectra.ai enabled. After installation, I'm going to create new testing framework. We'll call it Rapise 9 Demo. Click on Web, and you see Starting AI module. It checks the presence of Inflectra.ai, and since it didn't find that this Rapise instance is connected to Spira with Inflectra.ai, this checkbox is unset. I'm going to link them, so I'm setting this checkbox and I'm followed to the Spira connection settings screen. Alright, going to my Spira instance, taking this URL and using it here. Now I need username and API key. I may just click on this API key and copy it, use it here. Now do the same for username. Use it here, assign some host token and test connection. Connection is successful. So after connection is successful, you may see that Inflectra.ai is finally enabled. So saving it. So this checkbox is now set. So we are all set for self-healing and for AI integration. Okay. And new testing framework is created and I'm connected to Spira. Now I have testing framework and I'm ready to add a test case. Adding one, we'll name it, let's try self-healing. To be clear what I'm going to demonstrate, as you may see, it has AI recorder enabled. This is important because this would enable self-healing for all recorded objects. Choosing RL, our language, and I'm ready to begin. I can hit record here, or I may choose record for this specific test case. Recording activity dialog shows up, browser shows up because it's a web test. And now it should ask me the start URL. So let me start with the initial version of library information system and do some interactions, very basic. Username, password, click login, click logout. Now I'm about to press finish, and this is the first time you may see some difference from what Rapise was doing before. With AI recording enabled, you may see that it is busy with something, and this something is here in the bottom side of the screen. It's saying encoding. So now it is preparing some essential data for self-healing that would be used in the future. So now it's using AI for this purpose. All right, recording done, and I'm all set. I have a simple test ready, and if I just play it, it would simply work exactly as before. Just enter data, log in and log out. Very quick, and all the interactions are identical on how it was before self-healing was introduced. And this is by design, so self-healing is only enabled when it is really needed. Now let's create a need for self-healing. Suppose that our application has changed and we want to switch to different version of the application. So we have like Angular based version, so the different UI covering the same functionality. So let me use it as initial URL in this test, and let me play this test again. So while application looks similarly, it is different, and objects have different locators. So now it is supposed to find that default location is not working, and additional efforts are required for the test to execute. As you may see, the execution is slower right now because it's unable to find object by default. So first it tries to find an object using regular ways, because there are some amount of time for which Rapise tries to relocate the object, and usually by default it equals to 10 seconds. And when these 10 seconds are passed, the AI logic is enabled, and self-healing is invoked to locate the object based on information that is present on the screen. So the test has been executed, and unlike the previous execution, right here you may see there were additional interactions that were involving AI. These interactions were dedicated to find something on the screen. This is the self-healing. But we are not going to dive into that. It's just a note that something is different because self-healing was enabled. Here in the bottom we may see summary. So these three objects had to be located using self-healing and AI. And I may press apply patch. You may see the patch file is here, and it shows what was the differences between previous location of the object and new location of the object. I may simply apply all the changes by pressing all at once. This is what I'm going to do, and click all done. So my object repository are now patched to work with this version of the application. So if I play the same test now, it should execute really quickly because the object repository has been updated, and it now works just as before, but with new version of the application. So this is a demonstration of self-healing in action. Here are some facts about self-healing. You need to have Inflectra.ai subscription for self-healing, and you need to connect Rapise to Spira with Inflectra.ai enabled, and you need to record your test cases with self-healing already enabled through AI Recorder tag. You may configure self-healing per test case, and when you execute the test that utilized self-healing during execution, you will get a patch that you may apply to your object repository. Patch is a result of self-healing.
Next up in Rapise 9.0, we've integrated Inflectra.ai directly into test case playback. This means you can now bring the power of AI into your tests to perform smart visual checks of the UI, analyze and generate text, and even guide the execution of your test cases. And behind the scenes, Inflectra.ai is also powering self-healing for your web tests. Let's see how it works. I have a framework, and in my framework, I have Inflectra.ai turned on. This is actually now the default option if you are connected to Spira Test. And in my framework, I have a couple of test cases that will demonstrate how you can use AI features at runtime. First of all, let's take a look at global object section here on the left side. You can see that AiTester object is now here. So before in Rapise 8.6, for example, you had to install AiTester as a public global module in your framework. Now, since Rapise 9.0, AiTester is included as one of the default global objects. And using AiTester, you can send queries to LLMs, you can send text queries, you can send image-based queries, you can do assertions. So all these features are now available with Inflectra.ai as well. So let's see what we can do. I have a couple of test cases here, and both of them are using Spira test as an application under test. So let's first run this one, summary graph. So let's quickly see what it does. It should log in into Spira test. It should navigate to reporting, take a look at some graph, and then do some visual analysis of this graph to determine which test cases failed from which components. So let me quickly run it and I will show you the details. So I am running this test case. It should open Spira test and then navigate to reports. So it's entering username, password, login. Here we should sign off the other location because I was logged into this system from another browser. Okay, this is our test case summary graph. And here we get the report. So let's quickly return to the application itself. We are in the reporting. We have a graph which is effectively a picture. It is a SVG element. And here we see execution of our test cases break down into components. And it may be hard to determine test cases for which components failed, for example, if you try to do it programmatically by analyzing the page. But with AI, this task becomes very easy. So we just send the picture of this graph to AI and asking which components have failed test cases, and we get the result. So let's quickly look at this report, execution report. So here we can see the screenshot of the object, and this is our query. So let's please return me comma-separated names of components that have failed test cases, and it correctly AI correctly returns me book management. So this is the only component that has failed test cases. And then I can do an assertion and check that this list of failed components is correct. So this is how you can use AI to perform some advanced visual checks during test case playback. Also, let's take a look at one more line here in the report. So if you remember, then during execution, we had to click on sign off the other location button, and how we determined that we need to click on it. So there are various ways, but with AI, it becomes very, very simple. Let's quickly go to Spira app module that I have that performs the do login action. And here you can see an if statement that just runs do web image query for the whole browser window. And it just asks LLM, do you see sign off the other location button? So if this button is present, then we click on this button. If not, we just continue our test case. So this is the example of AI-assisted decision making during test case execution process. So let's take a look at one more test case here. We will analyze some complex label on the page. So let me run just a part of it so we don't need to log in again. So I will just run this part. It should navigate to incidents module and then check the label that displays the summary of how many incidents we see from how many incidents in this product. So let's see. This is the label we are talking about. And here we can see that we are displaying 15 incidents from 60 incidents. So if you want to check this number, 60, you can, of course, get this string. You can parse it using JavaScript, extract it, and then analyze. But if you have Inflectra.ai, then non-technical users can do a very simple check. Let me return back to my test case. So we simply read the text from the label, and then we send a text query. So our text query is this: what is the total number of incidents? And we are just prepending this query with the text that we see on our label. And then LLM just returns us the number that it extracts from the string. And we then compare in this assertion that this number is what we are expecting. So this is the example how you can do text-based queries using LLM and leverage the responses of AI. Now let's talk about workflow improvements inside the Spira dashboard. We know that managing large test suites can involve a lot of repetitive clicking. So we've added check and uncheck all menu items to speed up test case selection. We also wanted to make configuration of tests easier. There is a new Apply Local button on the Parameters tab that lets you easily switch between configurations and validate your changes locally. It is very easy to use these new productivity features of Spira dashboard. So I have a framework, I have a test set selected, and here I have a hierarchy of my test cases. You can see that I have some folders inside folders, some root test cases. So before Rapise 9, if you wanted to include some test cases into test set, you had to manually click on each individual test case. But now it becomes very easy with new pop-up menus like check all, uncheck all, and check all recursive and uncheck all recursive. So for example, if I want to check everything in the current folder and all the folders and test cases inside that folder, I can do check all. So for example, here test coverage is at the root folder level. I can right click it and do check all recursive, and you can see that everything is selected. Let's do the opposite, uncheck all recursive. So everything is unchecked. If I want to do this just for some folder, I can right click this folder, or I can right click any test case inside it and choose check all. I can check all here as well. And if I want to uncheck all of them at once, I can right click some test case and do uncheck all. So this is a very fast method of including and excluding test cases from a test set. So if you have a framework with hundreds or thousands of test cases, you now have an easy way to organize your test sets and include test cases into your test sets. Another productivity thing is this Apply Local button on the Parameters tab. What it does is simply allows you to quickly switch between configurations that you have for local execution of test cases. So for example, if you want to run your test cases using borrower username and password, you can click Apply Local. You see test execution parameters dialog. You can see all the values in this dialog like you see here on the parameters tab of the Spira dashboard. You click OK, and then if you will run any of your test cases, it will use these parameters. Actually, this is a shortcut to this button of playback settings in the top right corner of Rapise. So if I click it, I see the current values of parameters that are used for local execution of test cases. I can also quickly change configurations here as well. So if I want to use default configuration, I change it here, and now my username is librarian. Clicking OK. If I want to change it, I go to read only, I click apply local, and again I have borrower as my username. So there are two ways, apply local button and this playback settings button to quickly change configurations for local execution of test cases. Our next Rapise 9 enhancement is the new SetTestRunCustomProperty action of the Spira global object. It improves how you capture test execution data. Instead of forcing you to hunt through long reports and text logs for a dynamically generated order ID, transaction number, or any other important value, Rapise can now grab that specific value and save it directly to a Spira test run custom property. By turning test output into structured data, you unlock advanced filtering, custom reporting, and trend tracking across all your runs. It's a small change that makes your test results more actionable. Let me show you how to set this up. This is Spira Test, and I'm logged into it using administrator account. So I have my project selected, and I go to test runs. And here I can see test run custom properties. So here I defined custom property environment of type text, and I will use it with Spira SetTestRunCustomProperty action. So let's go to Rapise back, and this is my test case, and it just calls this Spira SetTestRunCustomProperty. And this is the name of the property environment that I just defined inside Spira test. And here I will be setting up some test parameter. So in Spira Dashboard, I have defined parameter with name env, and I will set the value of this parameter for every test run that I will do. Actually, I already executed my test sets multiple times with different environment values, and as a result, I received a sequence of test runs. So let's go here. Some of them passed, some of them failed, and let's quickly show our custom property environment. So here we go on the right, and you can see the value of this environment property that was set by RapiseLauncher when it executed this specific test case. So I have a custom property. I can set it through execution inside RapiseLauncher, and as a result, I have environment column here that I can see inside Spira test. I can filter this column to find executions related to this environment. So here I can do filtering. Also, environment is a bit artificial example because here I have a test set name that corresponds to the environment as well, but it can be something different as well. Also, you may put here, for example, the product ID or transaction number, so something that you don't want to search for inside logs and lengthy reports, and you need to quickly find this information for a test run to do troubleshooting with your application under test. So we can do filtering, but most importantly, we can do reports and graphs using this custom property. So let's go to reporting here. And let's create a test run summary report. So here, if we will scroll this down, we see this environment value. So we can define a filter based on environment. If you want to have a report just for production executions, we can type here production, if only for QA. So it helps us filter the values. Another interesting thing is you can do graphs using this custom property. So actually, first you need to define such a graph and then add it to reporting dashboard. So let's go here and navigate to System Administration, Reporting, Edit Graphs. And here I have some graph defined, test runs by environment, and we may edit it and see how it is organized. There is a name, there is a query, and I can do some preview, display data grid. I can preview graph itself, how it will look in my dashboard, and when I am satisfied with it, I can add it to the dashboard. So how to write this query? So it actually looks pretty complex from the first side, but the good news is that you may use AI to build this query. So for example, in Rapise, you can go to AI dashboard, you may create a generic chat session, and then you may type something like in Spira test, I have to run custom property. You just need to spot the ID of this property that you created, some additional information, and then your question. I want to define a custom graph and show past failed status for each environment. It will generate you the exact instruction how to do this. And in my case, it did not provide me with the query to insert from the first attempt. So I said to it that write me a query, and then I got a query and I inserted this query and I have these graphs. Now I can go to again to my dashboard, to reporting. I don't see this graph at the moment, so let's edit this view. And let's click Add Items icon, Custom Graphs. This is my custom graph, and I want to add it at the top of all other graphs. So clicking it, clicking Close, and this is my graph. So with this custom property, I can create graphs, I can create reports, I can do filtering in test runs if I need to. I can immediately see some structured information if I will define a custom property like transaction ID or something like that. So Spira SetTestRunCustomProperty feature helps you to get more out of Rapise and Spira test integration.
Now let's discuss running Rapise tests with GitHub Actions. The prerequisite for this is to have a test set that is safe to Spira, and we need to have Spira API key configured as a GitHub secret. Then you need to know how to find an action on the marketplace, and this is what we are going to cover now. I've got a test that were created earlier today. As you can see, everything is green, so it's passing successfully. Now the next step is to prepare this test for CI/CD execution. To do that, we need to save it to Spira. So let's switch over to the Spira dashboard. Here, all we need to do is to select the checkbox next to the test to add it to the test set, and then save it to Spira the usual way. Go ahead and accept any prompts, and in just a moment the test will be saved. Once that's done, we can see the test set ID in Spira. It's displayed right here. And that gives us a URL for the test set that we can use going forward. Now we are ready to create our first GitHub action. While in the repository, we go to Actions, and I'm choosing the default option, set up a workflow. Here in the Marketplace section, I'm typing Rapise, and I'm getting two options, one for Windows and one for Linux. Linux is better when you have web or API tests, so I'm going to use it. Once it is here, I may either choose the default suggestion for my action, which contains a lot of options, but I'm going to use simpler variation. For this purpose, I'm clicking View Full Marketplace Listing. It's sort of README page for the action, and it contains some snippet that I may simply reuse as a whole. So I'm copying it and pasting it into my workflow. All I now need to do is to finish setting some parameters. First is URL, and I'm going to simply get it from the URL of my test set. Next is username, and I'm simply copying the username from the user's profile in Spira. I have already configured the Spira API key, and the last option is the automation host. The default is GHA, so I may either create such a host or make sure such a host exists, or use existing host name. Let me look at my repository, go to automation hosts, and here I can see two automation host names. I may simply create GHA, for example. So I make sure this repository contains GHA automation host, so I may execute my test set. All right, so once it is configured, I may simply save my workflow, go to Actions. Now I can see my action here. So I'm all set to execute. It's all set, so I hit Run Workflow, running it now, and execution starts. Usually it takes from 1 to 2 minutes because this step contains installation of some prerequisites, then execution of tests, and then publishing of results. For Windows actions, it's a bit longer. For Linux actions, it's a bit faster. But when I'm executing just one test, it looks like slow, but when I have hundreds, usually all preparation anyway take like a minute, and the tests take as much as they need to take. So let's wait for it to execute. I can click here, and while it is running, I may see the execution output. It's running. I may expand the log. So I may see that my test case is already executed successfully. This is the status. And the artifacts from the execution were published. It's now finishing some summarization of the run, but without waiting for them, I may already see the execution artifacts. You see, they have been downloaded, and I can watch the launcher log. I may see XUnit test results, and I may see some additional files that are related to this execution. So my execution is green. This means that GitHub Action integration is successful. I may now go to Spira or to Rapise itself and watch the test runs and see that my GHA execution were successful. This is the run that I have. And I may see the same in Spira itself. So this is my test set. I may see test runs, and this is my last successful run. With all steps and everything as we expected to see here. As usual, when you need to get additional information, you may go to rapisedoc.inflectra.com, and in our case, if we are interested in CI/CD integration, we can go to KB. There is a topic regarding GitLab, and there is a topic regarding GitHub Actions with all additional details and explanations. We just managed to successfully configure and execute a Rapise test set using GitHub Actions. We used the action published on the marketplace. We used the manual that is available through rapisedoc.inflectra.com. We saw that the action is available for both Linux and Windows hosts, and you may have it GitHub hosted or self-hosted. The prerequisite is to save the test set to Spira and to configure the secret Spira API key. Now let's talk on how to configure GitLab for Rapise test set execution. Integration with GitLab is similar to GitHub, except that those systems have some intrinsic differences. For example, there is no marketplace for GitLab. That's why you need to define all the steps right in your pipeline. And from the knowledge base, you may get to the topic where you may get all the required definitions for your pipeline to have Rapise tests executed. It contains sections that cover Linux execution, Windows execution using Windows provided by GitLab itself, and your self-hosted Windows. After execution in GitLab, you should get the test execution results as shown here, because GitLab has this feature. So to have GitLab executing your Rapise test sets, we recommend you to follow this topic. You may go to rapisedoc.inflectra.com, open knowledge base article 947, and find snippets for Linux execution, for Windows execution, and for self-hosted configurations. Today we explored what's new in Rapise 9.0. The big highlight is Inflectra.ai, now running during test playback, enabling features like self-healing without needing your own AI credentials. We demonstrated powerful scenarios like visual assertions, dynamic text analysis, and runtime decision making. We also showed how the AI dashboard can help with tasks like Spira report creation. Finally, we covered updates to the Spira dashboard, custom test run properties, and CI/CD integration with GitHub Actions and GitLab. Thank you for watching and have a great day.